Okay, so we're going to find the perimeter of the quadrilateral. Quadrilateral, I'm having trouble saying that, is a shape that has four sides. So I'm looking for the area of this four-sided figure, the outside. All right, so I know that I have a 45 right triangle here. So that means this side length and this side length are congruent. I have a 60, 90, well, that's 30. Okay, so, all right. So right now I can use the rule of a isosceles right triangle, and I know that this side length has to be 36, which makes this side length, okay, excellent. Now, the trickier part is the altitude of my 30-60 right triangle has a square root of 2. And I know that that triangle normally has a square root of 3 in it, right? So what do I have to divide 36 root 2 by to get this side length? Square root of 3. So we're going to go 36 root 2 divided by the square root of 3. Well, can I have the square root of 3 in the denominator? No. So I need to go ahead and rationalize the denominator. So square root of 3 times the square root of 3 is 3. So we get 3 underneath 36, and root 2 times root 3 is root 6. Now I can have root 6 in the numerator, that's okay. But I have 36 over 3. That can be reduced. So what does that reduce to? So we get 12 root 6. So this side length here is 12 root 6. Well, what does that make this side length? That's 24 root 6. All right, so let's add this together. I have 36 plus 36, so that makes 72. And then 12 root 6 plus 24 root 6 is 36 root 6. That's sort of interesting how it came out. Now, can I combine into one value, one term, 72 and 36 root 6? No, because this is a root 6, this is not. So the only thing I can do is leave it as an irrational number. Now, if it said round to the nearest whatever, I can find the decimal equivalent of root 6 and multiply it by 36. But that's really where I'm stuck.